That's Stephen Arcaro. I'm John Mclaren, and we are half of the team that worked last year on a game called Madcap Dash, and we decided at the very start of the year to use XNA. So we're just going to sit here and talk a bit about what we found out about XNA and just how useful it was for making games and stuff like that. And I think Steve's got
any questions, yell out.
Yeah, got questions, just yell out. I'm pretty sure Steve's going to run through a little bit of the programming that we did for it and just how easy it is to sort of set up stuff that you need for a game in XNA really, really quickly. So we'll start by pushing the next button on the laptop. There we go. XNA. Steve, your job.
Well, they volunteers.
It's okay. They wanted to learn. It's good.
Right.
Go, Steve, go.
So, yeah, we chose XNA for our project. So why is it good? It's really easy to pick up, and the next 3 points as well. So it's really easy to pick up. It's in C# for the bulk of it. So that's like, you don't have to go to any low-level digging around in memory and all this.
The XNA presentation? You don't have to be quite so stealth about it.
Yeah, very cool. And so, like for instance, loading in a model, which to do in something like DirectX or OpenGL is absolutely disgusting. Requires pages and pages of code just to load in a model with like
a 3D model with some textures on it.
And we could do it in like one line.
Yeah, XNA, it's content.load model.
Yeah.
It's pretty good. Like, if you just want to get like a really quick game up and running, it's really, really nice because it sort of, it gives you everything you need. Like, you don't have to think about sort of how to fill the screen with like the color black. You just can just go clear screen black, and it works really, really well. It also is really, really well supported. You run it through Visual Studio, so you get all of the documentation and the code helpers along with it. Like if you start to type this really long string, it probably knows what you're asking for and will help you along the way. And also the community and sort of the examples that come with it. There is a massive online community around XNA and developing stuff. Like chances are, if you're coming up with a problem in your game, like I don't know how to do this, someone's probably like thought about it. Someone's probably had the same problem. Someone's probably written an example or a tutorial that you can follow to help sort of figure out what's going wrong.
Yeah.
So yeah.
There's heaps of stuff like we got the camera for our game.
Yeah.
Basically from like a spaceship, following a spaceship camera, which works really, really well. It has like a nice tug and
actually,
stretch around.
Do we just want to show our game?
Yeah, we should do that.
Yeah, we should.
And we've got the environment here, so we might as well show the environment you actually use.
No, we've got it on PC. It's. It's not as complete as we would have liked. In the third year of the IT degree at Monash, you sort of have a segment where you work on something for a commercial enterprise. So, like, if you're doing, I think, the information security systems major, companies will come in and say, we have this problem, can you write a solution that'll solve it? And you'll work in a team.
The games is really cool.
The games development major is slightly different because it's really hard to convince game studios that they should let uni students come in 1 day a week and work on their games that real publishers are paying a lot of money for. What they do instead is turn around and say, okay, form teams of 4, and by the end of the year you'll be making a game. You'll have a game at least completed. Is it Invader? No, it's a racing game. Multiplayer, Xbox, 4 players.
Well, you can say it's probably done. Just like a tutorial would be good, but that's about it.
Yeah, it's you probably need more significant controls. We're playing it on PC. It's meant to be played on Xbox, but we couldn't actually get it onto the Xbox in time to be able to show it. So
another really good thing about XNA is you can easily just port your game over to Xbox pretty quickly. You can basically just say make a copy. If you can see here, I've got the 2 main projects for the game, these two.
A physics engine.
Basically an Xbox 360 copy of these projects.
And so every time you compile it, it creates an Xbox version. If you've got an Xbox connected to your computer or connected via wireless, it'll go, do you want to send it to that? Yes, okay, and away you're playing. Yeah. Like about 30 seconds.
You just change that switch right here. You just say either
computer,
x86, like your computer,
or Xbox 360.
So
Yep.
That's basically the only thing you have to
that's the only thing you have to think about is how do you get everything that you need to onto the controller and just write something to look for, it's basically, in XNA, it's just basically if Xbox 360, and it goes, okay, so I'm on Xbox 360. This bit of code runs. It's really simple. Like our entire like input handler, like everything we do with the controller or the keyboard is like, if Xbox, if not Xbox. It's really that simple.
If not Xbox.
And then we start looking at keyboards.
So then we're looking at keyboard stuff. So
and then we skip a little bit, and then a little bit further down. That else there, it's like 70 lines of code. And because we're in the PC version, it's all commented out. Like it just says this won't run. But that's all of our controls for...
So we're looking at things like triggers, like the right trigger here.
Like the triggers on the Xbox. And you can just look at all the buttons by just going, you know, it's actually down here at the bottom, if current gamepad state dot button left shoulder, so the button just above the left trigger, if that's on, off, and you can do all sorts of stuff with it. Let's show them the game.
Yeah.
And hopefully the audio will work and not be too loud. I'll just turn it down.
For start.
Yeah. Yeah, it's so gonna crash now that we've like just put it up.
Oh wait, no, it's here.
No? Hey, there it is.
Hey, in bad resolution.
Oh yeah.
Check it out.
Cool. Did you bring your gamepad?
No.
No.
And so on this game specifically, Steve was lead programmer. I was the project manager, sort of, and miscellaneous other. So I actually did all of the 2D art for this game as well. Not textures though. Our 3D artists did them as well. We sort of went for a very much sort of cartoon feel to the game. We sort of, if you wanted to describe it in a sentence and compare it to other games, you'd sort of go, this is Mario Kart with a bit of a twist on the Xbox. That's sort of where we were going for it. So I think we can only actually add one player because we're on the keyboard. So hit it up.
Is it enter?
Yeah, I'm pretty sure it's enter.
I hope so. Space. No, it's space, I think.
It's something.
Yeah, space.
There we go. And so there it is.
Oh, I missed all the prizes.
Oh, got a rocket. Awesome. And an anvil. Yeah, so this entire game at the moment was just one track. 3 laps around, first to complete wins. And so all of this entire track, the go-kart, and all of the sort of 3D models that we needed for other upgrades and stuff were entirely done by our 3D artist, who is awesome, basically.
Yeah,
we just sort of turn around... Sorry? Yeah, we went for the same sort of tone shading outline.
Very much inspired by like things like Toy Story as well.
Yeah.
Like really cartoony.
One of the things that's really good for like when you're starting a game, just in general, is if you have a visual idea of what your game wants to look like, you'll find it starts to inform other things. Like because we knew very early on we wanted to do the cartoony style graphics, and so we decided. Yeah, he kind of fell off into lava.
Deliberately.
Okay, deliberately.
I wanted to show people the lava.
Sure.
It's my favourite part.
But so this one level and getting it playing with 4 players roughly smooth on the Xbox was quite a bit of a challenge, but it turned out pretty well. Now let's see if I can't find a rocket on it. And that's the rocket.
That was a barrel.
Okay, you're upside down. I think H.
H. Oh,
Yeah,
yeah, that's right.
there you go. I can still remember the debug controls almost 6 months after we stopped developing this game.
And if you already haven't noticed,
yes.
anyone likes Top Gear.
If anyone likes Top Gear, our driver might happen to be the Stig. Except we gave them all different coloured jumpsuits and go-karts because it's the easiest way to tell who's one of 4 players.
It's really hard to tell which way to turn.
Yeah. Someone spotted the duck. That's actually a multiplayer only sort of power up, I suppose you'd call it. When you activate the duck, everybody else on the track for 3 seconds becomes rubber ducks, and they just slide out wherever they are in the course. Kind of like you just picked them out of the bath and pushed them along. Like,
ducks are slippery.
And ducks are slippery. The paint bucket drops paint cans.
Do you remember the debug controls?
What button do you want to push?
The paint bucket.
Try RT or Y. We just fired the duck, so someone else got hit by the duck. It's RT, Y, and U.
Oh, that was the voodoo doll, I think.
Okay. Oh, there we go. We've dropped some. So the paint can is really good because it just sits there on the track until you run into it, and then hit it.
So it's like manually activated squid.
Yeah, pretty much, except it's really fun because if you time it right, you can drop it straight into someone's path, exactly like you do a banana in Mario Kart. Hilarious fun, because they're just like, I can't see anything, it's all so colourful. Yeah.
If you haven't noticed, it's magic more than one colour in a bucket paint.
Yeah. It's rainbow paint, yeah.
Rainbow paint. It actually says on the paint can, magic rainbow paint.
I think it does, but you can never really get close enough to the paint can to see that.
You can if you stop.
Oh yeah, and the sandwich. RT. And yeah, pretty much the sandwich.
So that's our like little. Yeah.
Basically just a bit of a throw to Team Fortress 2.
Yeah.
As fun as it is, I'm pretty sure we've shown them enough of the game. We might get back to sort of how we made it.
Yeah, our 3D designer really liked Team Fortress 2.
Yeah. Whilst we're sort of making this, our 3D artist was like massively into Team Fortress 2, and so basically he's just like, no, I'm gonna make the sandwich my way. And then, do you remember that poster, like the wallpaper that you could get for your computer, which was like how to make the sandwich?
You didn't notice there's a sandwich. There's like sandwich.
Yeah, and there's like
things everywhere.
Yeah, he just went nuts, and we're just like, yeah, we've got more.
Pretty much free range.
Yeah, we're sort of sitting there going, we have a lot of stuff still to do. Like we have to make sure that the cars don't freak out and just like fall off the track.
Oh, I got some lava.
Yeah, you hit the lava. Well done, Steve. No, it's a punishment in a way, but you can use it to your advantage because it freezes you in place for 3 seconds and turns you into a sandwich, which is excellent because it's like a portable wall. So if you really want to screw with someone, if you position yourself quite right, if you're going around the lava bend, you hit yourself, turn yourself into a sandwich. They hit you, spiral off, fall into lava. Hilarious.
Dude, stop going sandwich on me.
Yeah, pretty much. Like when you'd play it, you'd just be like, ah. Okay. Yep.
Once the game is more finished, do you have any intentions of bringing like online multiplayer into it?
We had a look at multiplayer online, and it was a bit outside the scope of the amount of time we had to do it in. Because when we're doing this in year 3, we had 3 other units. So we had 3 other subjects that we were studying at the same time as making this. And as awesome as it would be to just be able to spend an entire year to create a game at uni, it's not going to happen. Like you do have other things, and so you really sort of have to like maximize your time. Yep.
Are you going to continue in your groups to develop the game more, or is this where you're going to stop?
I think by the fact that we probably haven't worked on it in about 7 months, this is probably where it's gonna. It's probably where it's gonna end. Yeah, we sort of talk a bit more about sort of how to get through the second half of making a game towards the end. But I think we'll go back to the start of when we're making a game, and how to come up with that idea that will, be fun enough to play and fun enough to make.
So as well, is anyone doing the challenge? That's
the game design challenge.
The game design challenge that's finishing tomorrow.
Yes, got a couple of you.
Cool, that's really
awesome.
Good. Because we might give you some tips.
Yeah, we might have some like advice for you on how to make awesome games.
Yeah.
Might.
So first you got to have your idea. Yeah, first you got to have your idea, and you want it to be like you want to have some uniqueness. You don't want to
Yeah.
Everyone can make another first-person shooter.
Yeah.
As cool as they are.
And everybody wants to work on like the next COD and stuff like that, but you need
a selling point.
Yeah, you need something that'll make people look again at what you're doing. Like you need something that people go, oh, I've never heard of that before, or I haven't seen that before, or I haven't seen that combination before.
Any good game that's coming out now always has its thing. If you look at, we've got like Brink, that didn't really work out, but
it tried really hard.
It's got people's attention. People were like, oh, first-person shooter with some like running parkour elements. That's pretty cool.
Yeah, you'll find a lot of people don't necessarily want to play a game around Playboy. Like, there's a very small subset of the audience that would probably, like, of the wider gaming audience that would enjoy that, and most of them are probably sitting in this room. It's sort of, the 15 to 19-year-old male.
Playboy.
Yeah, he was like superheroes and Playboy.
Well, like...
Isn't that just Duke
Yeah, I was about to say, that's pretty much how Duke Nukem got his first scene, isn't it?
Yeah, it's pretty much, yeah.
But all the jokes in Duke Nukem. And,
yeah.
That's what makes it great.
And so, I must admit, coming up with the idea is one of the hardest parts of deciding on what to make for a game, if you're going to make one yourself. Because, you know, you can sit there and, like, if you look hard enough, you'll probably find someone that has not stolen your idea, but come up with your idea before. And so it's really hard to sort of strike the balance between doing something that no one's ever heard of before and everybody's sort of looking at it going, why would we want to play that? And making something that's approachable and yet fun. Although, once you get past the idea, it's really actually kind of awesome because you can go wherever you want with it. Like because you're essentially sort of making the game yourself, you're the only one who gets to decide what you do with it.
Yeah,
and then
you've got a lot of freedom.
You get to decide what it wants to be on. You get to decide whether it wants to be on Xbox Live Arcade Indie Games, XBLIG. It's an awesome acronym. And you get to choose whether it just wants to be a PC game or something else like that. Yep.
How big of a problem is it if someone has had your idea before?
You never want to really make the same game.
Yeah, you don't really want to make exactly the same game as someone else, because then, if nothing else, you're just showing off that you can copy other ideas really well. And whilst that might get you a job in some game studios that just sort of make ports and stuff of other games, there's not really much of an audience for I made COD 3 or COD 2. I made COD 2 again. It's like, okay, but another team working for years made COD 2 the first time.
On the same take though, if you wanted to do something as an exercise, purely as an exercise, yeah, sure. Like I had an assignment last semester that was make Pac-Man but in 3D from scratch, which was
So, but just doing stuff like that also shows that you're interested enough in games to want to do the hard stuff, because working in the games industry is not always just sitting there and playing games. If it is just sitting there and playing games, you're playing the same level for 4 weeks trying to find all the bugs in it. And it's not necessarily always as fun as you think it is. So whilst you're young, whilst you're not actively out and looking for a job, making a game in your spare time is one of the best ways to show just how dedicated you are to it as well. Just thought I'd throw that in there. Do you want to move on, or
move on.
See if someone's coming in? No? Yes?
Come in!
Play. We're awesome, honest.
No.
Very interesting.
Oh. Yay! Hey! Cool. Do you want to learn how to make a game with XNA? Wow, don't sound so enthusiastic. I don't know.
Oh, well, you just missed the cool demo.
Yeah,
all the prizes.
Yeah, you missed all the prizes. I think almost everyone in here. Oh, yeah, prizes. Yeah. So the prize is just outside. We'll have to go get it. No.
So
I can't even remember what we were thinking when you put this slide in.
Yeah, well, I was going to talk about how we had ideas of what game we've already covered it.
Yeah.
What other games, movies, and things that you wanted to have as your theme and things running through the game.
So, like I mentioned before, our game was sort of the art style of TF2 and Borderlands combined with Mario Kart on the 360. That was, if you wanted to sum up our game in one sentence with using other games as reference points, that's where you'd start.
Yeah, it's a really good way to get your whole team thinking on the same level
as well,
and working towards the same goal. Because even if you think you are, you're probably not.
Yeah, cause we were working in a team of 4, and if you'd asked any one of us individually halfway through the year what our game was going to be, you'd get 4 very, very different answers, and we'd already been working on it for 14 weeks. It's just you need to make sure that everything is on the same level. And so this is just sort of a bit of a demonstration of exactly sort of what goes into our art, well, the art for our game.
What a model really looks like when you've got it done in Maya.
Yeah.
So this is what Tim did. I got to give all the props to Tim. One thing in games that I don't know how many of you guys think about when you make, if any of you guys make models or things like that.
Do any of you do 3D? Have any of you done any 3D stuff before? Okay, a couple of you?
Yeah,
cool.
Some things you have to think about is the poly count. You can see that the top of the sandwich is just one flat planar.
and then you
so
keep it all down.
Yeah, so the less polys you got, the better your game's going to run, and you can still get a really good looking sandwich, especially when it's cartoony. Yeah, it makes me hungry all the time. And so this is the cave. The cave
segment of our race, and it sort of just demonstrates, like, we found about 3 weeks before it was due that our game was unplayable on the Xbox with 4 players. And we spent ages trying to figure out what it was, and as it turns out, the easiest way to fix it was to pull unnecessary polygons and triangles out of our race, out of our track as much as we could, because we just had too much detail in there. And I mean, with our art style, you're not going to notice it. We're not aiming for sort of realistic or even photorealistic graphics. We're aiming for cartoon, and so that's probably something that we should have learnt earlier. Is if you know what you're good at, then work on developing that, but also work on stuff that you're not good at, because then if say you're working in the industry one day and an artist comes, because you're working as a designer or something, and an artist comes to you and says, I've got this problem and I don't know what to do, then you might have some idea of what they're talking about. Just as a small thing.
And textures do a lot of work for you. You can always have like a crate or something. You never have to model all the wood in the crate and all the ins and outs, all the wood. It's just a box with a slap on a texture that looks nice. And every game does it. COD will do it because it's going to actually make the game run. So this is the car in parts.
Frame underneath.
Got a little bit more detail.
Are you able to customize the car?
That was one of the things we talked about at the very start of the development process. We thought, it would be awesome if you picked up stuff during the race and you'd be able to put it on your car afterwards. But we very quickly learnt that with the abilities that our team had and the amount of work that we had available, we couldn't get the work done in the time that we needed to, because it's really strange working.
Now, sorry, a little bit of a timetable thing, right? These guys won't be moving. They'll be staying here instead of moving to R3. In an hour, or at 4:30, tournaments will start, and we'll tell you more about the games then, okay? So you guys can run into all that.
Yeah, after I'm doing a flash presentation.
Yeah, they're doing a flash presentation. We're doing a flash presentation somewhere else. They're going to stay here, okay?
Sick.
Because, Steve's just going to do some stuff in Flash afterwards. I didn't do as much, so he's better off for it, I think. Better off than I have a show.
We had custom colours of the car too in there for a while. Toying around. We never made it like a menu or system to operate it though, so keep that in time. And
when you're working with this like a strictly 2D game, would that be easier to fit in more into your game world? Since it's just 2D, you don't worry about polygons and stuff.
Yeah, of course.
Yeah, like a 2D game, at least made on current or even like older generation hardware, is no problem. It's when you start adding poly counts into the millions of things that it really just starts to slow down. And I mean, that's impractical. Like we never used that many polygons, but we still found that chopping them out wherever we could helped immensely for our game.
So on the tech side, you got to do a lot of work kind of for your designer, if that makes sense. Yeah, I was going to put a diagram there.
Insert diagram here.
So you got to think about what kind of game the designer from the design side, what they want. So how that's going to work. So we at first we didn't say Xbox. We just said we want a multiplayer racing game, and then we thought, well, multiplayer on PC is going to be pretty hard because you got to do network and deal with lag and all these other stuff. So we thought we'll do it on Xbox, and we thought, well, we'll thought a console. And then we thought XNA might be a good way to go because that lets you use Xbox as your platform. And we also realized that a few of us had Xboxes at the time, so that was pretty cool.
I think I was the only person on my team who didn't own an Xbox at the time of starting the game.
Yeah, but it also doesn't really matter because at the same time you can launch to PC, test it out on PC, and when you have an Xbox handy, you can plug in your Xbox and you can launch it to Xbox. The next thing is object-oriented design or object-oriented programming, which, has anyone heard of that?
Does anyone have any idea what we're talking about when we say object-oriented programming, object-oriented design? Okay, so there's like 3 of you.
So basically,
really brief example.
Basically in programming, a good way to think about things is in what they call objects. And then, so in a game world, an object a lot of the time is like a little physical object. So you might just have like a model as an object, and that defines what the model looks like, what textures it has, where it's placed in the world in like X, Y, and Z coordinates and things like that.
The way it's rotated.
All the rotations and scaling and everything like that. And then you can just say, oh, I want a chair. You pull in a chair and you store it as a model. You pull in a like turn thing and you store it as a model on a computer.
You store a desk. You store it, yeah.
And so that's why that maps really well to games. So if you've got spare time, look that up. Yeah, it'll help you a lot. And yeah, it's programming in general. Object-oriented programming is the way to go. Iterations. So we have to get really used to. I've got a tip, like don't get attached to your work. But like you want to have, like you want to be passionate about your work, but you want to be able to throw things out. You want to be able to take ideas from other people. And a lot of the time, we had a lot of trouble with that sometimes.
Yeah,
as the fights over whether the colour should be yellow or red or whatever, you know.
As the project manager, it was my job to sort out any disputes we had in the team. And so when the artist turned around and said, no, I can't do something, then we had to either figure out whether we still needed to create all the programming for the new feature that he was going to add in as the artist to the track, or whether we were going to sort of neaten up something else, you know, if we were just going to convert another system to use. Don't ever get so sort of only stand up for something that you really don't want to change if you're absolutely convinced you're right. Like if you're working with a couple of other people just in a small group, and you're really sort of really want to make sure that something in the game is done your way, then fight for it. But there might be a point at where you have to just go, actually, you know, your way works better. I remember we had a couple of weeks there, where we had very long discussions about certain aspects of the programming and the game design as well, because we were still sort of arguing about how upgrades should work and how power-ups should work and other things like that. And it can get messy, but if you're not absolutely attached to your work, it's a lot easier if you sort of turn around and go, well, I worked on this for 3 weeks, but now it's not going to work in what the game is, so you get rid of it.
Also, in like a non-fighting sense, if you're just making your own thing, it's awesome just to be able to, like, I've got pictures of the level I'll show you in a minute. First of all, the artist made like a basic level, and then we go, yeah, that's kind of cool. We want how about more of this? How about more cave? How about more? Oh, we wanted a volcano, so we want lava. Oh, we'll put lava, and that's cool. And then, maybe too much lava. We'll take this bit out. We'll add a mountain there. So that's the level as it started off in the top left.
That's actually one of the. I think that's the third copy of the level up in this top corner, because the track started in our game world as quite literally just the surface you drove on. There was no background decoration, there was no cave, it was just a flat piece of track that turned and curved the way that we sort of thought we wanted it to go. And then I think you're sort of comparing the top two images. The top was at about week 7 or 8 of the first half of the year, so we're about 8 weeks in, and then 4 weeks later he came back with the cave section, because we decided that the cave would be a much better idea for that segment of the track, because you can sort of see this patch just over here.
Looked like we wanted a bit of a tunnel, and then we sort of went.
It was just kind of boring, and we wanted something more interesting in there, because you want your game to be interesting. And for our racing game, we're like, we need something that, you know, will actually be cool to watch. And so we went cave, and so the cave got added in. Then we started adding a little bit more decoration around it once we were happy that the track laid out the way we wanted. And then, as you can see it, sort of at the final point, down in the bottom corner, that's the same shot from essentially the completed track.
Yeah. Also, one thing we had to think about was, in racing games, we never noticed this until like a few weeks till the end, and we noticed that every racing game that I've ever played, at least, has big fat arrows that tell you where to go, and we of course knew where to go because we built a level, so we were just like, easy. This is like, so it sounds like a really stupid thing to say, but if you've made something, you can be so like blinded to how other people might see it, so you just got to get enough people to play it as well.
Yeah.
And so people would play it, and then they'd use the rocket boost or something, and then they might spin out or whatever and crash, and then they start going the wrong way. And we were like, we need to tell people that they're going the wrong way. So we added arrows around the track everywhere, and we brought in the wrong way system that flashes up on your screen and things like that.
Yeah.
So, any questions?
Yep.
A couple questions.
Sure.
Question number one, how many polygons did it take to make it not work on the Xbox?
Oh, I can't remember the exact number, but we were working on something. Like I think it was partly the way we coded the game, because we wrote almost everything on top of what XNA gave us. So we wrote the system for loading in the scores and stuff like that and all that. I think we got to about 80,000 polygons on the screen at once, and then it started to slow down, because what we forgot at the time was that we were loading sort of 80,000 polygons, and if we were playing with 4 players, that's a quarter of the screen. You're doing that 4 times over. It very quickly adds up, and that's something specific for us as a racing game. Like we want split screen multiplayer. We didn't think about how hard it was.
That was the biggest issue, that you actually have to draw your screen out 4 times
per frame,
essentially.
And in that bit, you sort of have a certain amount of time to make the game run at 60 frames a second. I think it's like 16 milliseconds.
16.7 milliseconds.
16.7 milliseconds to update everything in the game, sort of for 1/60th of a second, and then draw it out. And that's the only way you get 60 frames a second. I think when we were demonstrating the game at our final presentation, we had 4 players up on the Xbox.
About 25.
No, it was higher than that. It was
30
about
frames?
30 frames a second, and
So we're quite happy with that.
Yeah.
It still ran.
It still ran. It wasn't smooth. It wasn't perfectly smooth, but it went really well for what we needed, and so we're really happy with that. That was question 1. Question 2.
Question 2, what programs did you use to make it, and are they available? Like, are they free or cost money?
Oh, very nice, Steve.
I love the fruity things.
So, XNA specifically works in Visual Studio.
Or just Visual C Sharp.
Or Visual C Sharp Express. No, I'm pretty sure that's a free one for students. But if you had a way to compile it yourself, you could have just written it in Notepad. I did all of my art in Adobe Photoshop because I bought it. Tim did his art in Photoshop, and then in Maya for all of the 3D work. You can get sort of evaluation copies that work for 90 days, and they're a really good way to test out if you know the program or work with it.
Yeah. Also, student XNA subscriptions is free, I think.
Yeah, you can get an XNA subscription for a year, which I think gives you access to the indie live servers, and so access to the giant community we were talking about before. Was there a question 3? No? Cool.
So if Australians actually post their games to the indie program on Xbox Live? Only American?
No.
When we made our game, we couldn't, I don't think.
I think when we made our game, we couldn't, but I think they were looking to try and change that.
So it might have been changed.
It may have been changed by now. We're not sure, but I know when we were looking at originally making it, our game, if anything, was only able to be posted on the Australian network for Xbox Live. But I honestly can't remember now. It was quite a while ago when we were looking at it.
It might have changed.
Yeah.
Were the physics hard to do?
It was one of the things that we knew we weren't going to be able to do very well on our own because we didn't have much experience working for physics engines. So we actually found one for XNA that seemed to do what we wanted, and then spent about half of our time
Realising
working.
it was a bit slow.
Yeah, working on it to try and make it as fast as possible for what we needed. There's all sorts of sort of physics hacks that we've done. I think one of my favourites is all of the pickup boxes that are floating on the track. are actually just stuck there in space, and the only thing that will be able to move them is another pickup box or the player's vehicle. That's the only thing that will move them, because we found when we sort of let them drop onto the track, every frame, for some reason, even though they weren't moving, they were still checking the ground to make sure they were still touching the ground. And so that was sort of another thing that sort of we saved a lot of sort of processing time on and improved our frame rate no end just by thinking through things like that. In hindsight, like if we had to do this game again and we had another year to do it, we probably wouldn't use a physics engine. I think we'd probably write our own.
I don't know.
Well, we didn't really.
I would have done a lot more research into what physics engines and the pros and cons.
So to do a lot more work in thinking about what there was out there before we decided to grab this one.
I think you can get Havoc as a student version too.
Interesting. But no, we spent a good 6 or 8 weeks just working on the physics engine, just trying to get it up to speed. Because Steve did a lot of the programming. I did some. Our designer, Liam, also did some, and we actually just left Tim on art because we gave him, essentially, about halfway through, we just gave him this giant stack of models and said, here, make these. And he didn't like us very much for that. Adrian, how are we doing for time?
Cool, you've got till 4:30.
Oh, got till 4:30?
Yeah.
Well,
is this for both presentations or one?
Both.
Cool, because
okay.
I think we might wrap this one up very shortly so you can actually get onto your flash stuff. So I think the 3 of you that have got questions up, we'll just take them, so I'll go with you first.
No, sorry.
No.
Okay, guys, sorry.
After you've seen the finished product and sort of shown it,
Yep.
is there anything that you would have previously changed?
So,
Started?
after we finished the game, is there anything we would have changed before we showed it to people?
No, after you've showed it to people.
So, like after we've gotten feedback and stuff like that?
Based on their reactions.
I think to a degree,
I'd say a tutorial.
yes, but always. You'll always find something that you'll want to change after people have seen it, because it's something that we kind of got a bit of a shock to originally. Like halfway through the year, we had to give this big presentation, sort of this is where our game is at, and the feedback from just the other people in the class. Like there was about 20 people in the class, and so there were like 4 teams of 4, and then some other people who were doing some other stuff. I can't quite remember, but so there were 4 people making games, like 4 teams making games. And we very much just sort of, we did our thing, they did their thing. And so when you just got 12 other people who are all making games as well, sort of give feedback on your game, you sort of look at it and go, oh, okay, we really need to change some things. And yet there's always some stuff. Like I can look at the game and just go, yeah, if we had more time, that would have been awesome to change. That would have been awesome to change. You're always going to have to do it. It's actually one of the funniest things I remember reading about Valve. They're known for the phrase "when it's ready." You know, their games will come out when they're ready.
That's why they're so good.
That is part of the reason why their games are always really, really high quality. But it's also just something I think it's every week they get someone in who has never played one of their games before, sit them down in front of a game, play it for like 5 hours, and then they just say, so, you know, what did you think? Because their games are really, really well known for sort of explaining themselves, but that comes from trying it on so many different people to see how it works properly. So yeah, there's always stuff that you'll want to change, but at a point you just have to sort of go, no, that's it. You know, people get to see it now, or people get to play it now. Like if you're worried about showing your game off to people because you're not quite sure it's ready, you're never going to get feedback that might make your game about 10 times more awesome. It's just the way it's going to happen. Yep.
I don't know if you mentioned this before we came in.
Yeah.
Like, could you have done all of this in Game Engine and bypassed a lot of the coding?
I'm sure you could have, but we were looking at it as a sort of partly like a programming experience exercise. Like, I know Steve at least is trying to, you know, looking around at games programming jobs, and so we sort of went into it at the start of the year saying, what do we want experience in? What do we want to know? And I wanted to sort of do some management stuff, so I became the project manager. Steve wanted to do programming, so he was lead programmer. And we, as a group, we went, well, we all want some programming experience. We're going to try and build our own sort of racing engine and stuff like that. So yeah.
Same token though, XNA is a pretty good little engine.
XNA is a really good base. Like I think in the first week we had this little like grey cube flying around this empty blue space, but it was
got that done in a day.
Yeah, but it was awesome because we're like, we have a cube moving around a world. That's it. You know, we're happy.
Yeah. So you could actually do it all.
Yeah, if you're really, really patient, you probably could, but we found XNA was a really good move for us. And I think last question was here.
So when you ran into problems with the physics engine and frame rate drops,
Yep.
did you often look at online resources, or did you go to hold the code and experiment first to fix your problems?
One of the things that we did, at least I know I did, is there's pieces of software out there called profilers. And basically what they do is it's like running a really small digital stopwatch. And you say, sort of at the start of a piece of code, you say start here and stop here and tell me how long that takes. And so using profilers in different sort of pieces of our code is how we figured out which bits were running really slow. Like we just sort of came in it almost felt like we just came in one day, started working on our game, and it was running 30 frames a second slower. And we're just sitting there and we're like, what happened to our game? Where did it go? And after we sort of started looking over it all, we figured out that it was the physics engine. And then, yeah, we basically just jumped in and started changing things and seeing if it improved it. Like, I remember...
There wasn't many online resources for our specific physics engine either.
Yeah.
So, like, there was a few, but we had to really delve into it.
Yeah, we sort of had to dig into it. It's one of the problems with using libraries like this. You don't know necessarily how they work. So if you need to jump in and change things like we did, you have to spend more time that could be spent on your game trying to figure out how someone else wrote their physics engine.
Also, though, some libraries are completely closed. Some of our libraries are open. So our one was open, like we can get to all this code and we can look at the geometry primitives and stuff like that.
Yeah, so we could actually dig into our code and
custom physics engine
and look into it and actually see what it is. Some physics engines will just say, this is how you get physics out of our DLL file, go. What are you doing? You're running it in debug mode.
Yeah.
Yeah, you can see all of the stuff that we tried to check. Given that we have no more questions, well, I'm done anyway. Steve's going to probably play the game a little bit more. You can actually see up in the top corner here. That's our frame rate. That's our frame rate counter. The top number is frames per second. The second number, which flicks between like sort of zeros and ones. The other three numbers are timers for, I think, the update loop, the physics loop, and the drawing loop. And so that's in milliseconds. So if those three numbers add up to more than 16, then you're not getting 60 frames a second. And that was one of the most useful things that we could have possibly used, because we were just able to see exactly what was slowing down. Like when we ran it on Xbox, the numbers were still there, but they were completely different, which is one of the things that it took us ages to realize, is that the Xbox and the PC are completely different. For like the code's running here really smooth on on PC, beautiful. That code would probably do 50 to 45 frames a second on the Xbox, and we can't figure out. Well, at the time we couldn't figure out why. Looking at it afterwards, it was just something that we discovered and went, oh, this is actually, it's a known problem with the Xbox and the particular physics engine we were using. But yeah, it's always good fun.